Welcome to this video on discrete probability distributions part 2. After watching this video, you should be able to find the mean or expected value of a discrete probability distribution given a table or a graph, interpret the meaning of the mean or expected value of a discrete probability distribution, construct a discrete probability distribution given the frequency distribution for a discrete random variable, and lastly, interpret the graph of a discrete probability distribution. If you have not already done so, please watch Discrete Probability Distributions Part 1 before proceeding with this video. Mean or expected value of a discrete probability distribution. The terms mean and expected value are used interchangeably in regards to a discrete probability distribution. The mean or expected value is calculated by multiplying the random variable x by its probability p of x and then summing these products. We write this formally as mu of x, meaning the mean, is equal to the sum of the products x times p of x. Interpreting the mean or expected value of a discrete probability distribution. When interpreting a mean or expected value, it is important to understand that this value emerges over many trials. For example, suppose in 12 years of school, a person maintained a B average. Does this mean they earned a B on every single assignment? Of course not. They probably earned A's on many assignments and C's or lower on others. A person's GPA isn't reflective of their performance on every single assignment, but rather it's a summary of their long-term performance as a student. Much like probability, the mean or expected value is virtually worthless at predicting a single random event. However, it is valuable at predicting the long-term averages measured over a large number of trials. Finding the mean of a discrete probability distribution from a table. Example 1. Suppose you have a coworker who buys a bag of 5 cookies from a vending machine every day. Some days she eats all 5 cookies, other days she shares some of the cookies with you. Suppose the discrete probability distribution below represents the probability of the number of cookies x she shares with you. What is the average or expected number of cookies she will share with you per day? So here's our table. As you can see, the probability of her giving you no cookies, which means that she eats all 5, is 0.1 or 10%. Probability of her giving you 1 cookie is 20%, 2 cookies is 25%, 3 cookies is 5%, 4 cookies is 15%, and 5 cookies is 0.25. So the first thing we need to do, remember, to calculate the mean is that we need to multiply across. So here you can see that I've created a third column to house the product of the random variable and the probability. So for example, I'll have 0 times 0.1, and that gives me 0. 1 times 0.2 gives us 0.2. 2 times 0.25 is 0.5. 3 times 0.05 is 0.15. 4 times 0.15 is 0.6, and 5 times 0.25 is 1.25. Do you remember from a previous slide what we need to do with all of these values? If you said to add them, then that is correct. When we sum all of the values in this column, we get exactly 2.7. Now we need to interpret this answer. 2.7 what? What are we counting? Well, we're counting cookies. So now we need to interpret this value. So we would expect this person on average to give you 2.7 cookies. Now obviously you can't give somebody exactly 2.7 cookies, so we can say about 3 cookies per day. So does this imply, or is this the same thing as saying that you expect to be given exactly 3 cookies every single day? Is that what the mean or expected value means? The answer is no. Some days you'll get more than 3, some days you'll get fewer than 3. Remember, this is a long-term average of the number of cookies you will have. Finding the mean of a discrete probability distribution from a table. Example 2. Suppose it costs $5 to play a game at the county fair. You have a 75% chance of not winning anything, a 20% chance of winning $15, and a 5% chance of winning $100. Create a discrete probability distribution for your net profit and then calculate your expected winnings or losses over the long term. So here we can see that I've organized this into a discrete probability distribution. Where did this -5 come from? Well, it costs $5 to play the game. So if I win nothing, that means that I've actually lost $5. Then you might think that you would expect to see $15 on the table, but you can see here you only see 10. And the reason is if you win $15, since you already paid $5 to play the game, your net profit is only $10. Likewise, if you win $100, your net profit is $95. Then we've just filled in the probabilities over here based on what was given to us in the problem statement. How do we calculate the mean? Just like last time, we need to multiply across and then we add down. When we sum these three values, we find that the mean or expected value of this game is $3. What does this mean? Let's interpret this value. Pause this video, write down your answer, and then unpause it to see if you are correct. First of all, can you actually win $3 in a single game? Notice that none of the three outcomes represent actually winning exactly $3. So the expected value or mean of $3 means that if a person played this game many times over a long period of time, their average profit per game would be $3. Finding the mean of a discrete probability distribution from a table. Example 3. Suppose it costs $10 this time to play a game at the county fair. You have a 75% chance of not winning anything, a 20% chance of winning $15, and a 5% chance of winning $100. Create a discrete probability distribution for your net profit, and then calculate your expected winnings or losses over the long term. So if you don't win anything, you've actually lost $10 because remember now it's costing $10 to play the game. If you win $15, your net profit is only $5 since you already spent $10 to play the game. And lastly, if you win $100, your net profit is $90. Now we need to calculate the mean or expected value of this table. Remember, we need to multiply across and then add down. When we sum this column, we find that our expected value is -$2. What does it mean that our expected value is negative? Well, what it means is that we're actually losing money on average every time we play the game. But can you actually lose exactly $2 in a given game? No, that specific outcome is not possible. So what it means is that if a person plays this game many times over a long period of time, they would expect to lose $2 per game on average. Finding the mean of a discrete probability distribution given the graph. This graph shows the probability associated with the number of cookies X a person will give you out of a bag of 5 cookies. Create a table from this graph and then calculate the mean or expected value. So here you can see we have prepped a table. When we look at our graph, the first bar goes up to 0.1. So the probability that you get 0 cookies is 0.1. Likewise, we can see the probability of being given 1 cookie is 0.2, 2 cookies is 0.25, 3 cookies is 0.05, 4 is 0.15, and lastly 5 is 0.25. Once we have gone from the graph to the table, we can proceed as normal to find our mean or expected value. Remember, to do this, you need to multiply across x times the probability of x, and then sum that column. Doing this, we get 2.7, just like we had in a previous example. Constructing a discrete probability distribution from a frequency distribution. Suppose you are given the following frequency distribution for the number of tests given by the instructors in the CCBC Math department for a certain course. Use this table to create a discrete probability distribution. Let's look at this table. Why is this table not already a discrete probability distribution? Well, the answer is that these are counts and not probabilities. To convert counts to probabilities, we must sum the frequencies, as we've done here, and then divide each frequency by this total number, which, as you can see here, the total count here is 50. This is the same procedure we use to convert a frequency distribution to a relative frequency distribution. So let's get started. We can see here we have 5, which is our count, divided by 50. When we convert this to a decimal, we have 0.1 or 10%. Then we have 17 over 50, which is 0.34. We have 15 over 50, which is 0.30. And then we have 13 over 50, which is 0.26. Interpreting the graph of a discrete probability distribution. Use the distribution to the right to answer the following questions. Number 1. What is the probability that a randomly selected instructor gave 5 tests in Math 081 in a given semester? As you go through these questions, please pause the video after I read each question, write down your answer, and then unpause the video to check your answer. So the probability of 5 tests, as you can see from the graph, is 0.26. So that is the answer. Question 2. What is the probability that a randomly selected instructor gave 4 or 5 tests in Math 081 in the given semester? The probability of 4 tests is 0.3. The probability of 5 is 0.26. Remember, the word or implies that we need to add these two probabilities. So 0.3 plus 0.26 is 0.56. Question 3. What is the probability that a randomly selected instructor gave 3 or more tests in Math 081 in a given semester? 3 or more is 3 or 4 or 5. This time we have 3 probabilities that we add up, and we get a probability of 0.9 or 90%. Question 4. What is the probability that a randomly selected instructor gave fewer than 4 tests? Well, fewer than 4 is 3 or 2. Adding these probabilities together, we get 0.44. You should now be able to find the mean or expected value of a discrete probability distribution given either a table or a graph. Interpret the meaning of the mean or expected value of a discrete probability distribution. Construct a discrete probability distribution given the frequency distribution for a discrete random variable, and interpret the graph of a discrete probability distribution.